Hello everyone. Today we explore Feature Slice Design, or FSD, a methodology for organizing code to ensure structure, scalability, and maintainability. This approach is particularly valuable in front-end development, where uncontrolled growth can lead to chaotic code bases. We will examine the core principles of FSD, its layered architecture, and its alignment with object-oriented programming concepts. If you seek clarity in your projects and efficiency in team collaboration, this is what you need. Let's begin. Before we start, press like button and subscribe for more content. FSD organizes code using a three-tiered conceptual framework: layers, slices, and segments. Layers represent the high-level architectural divisions, such as app, pages, or features. They define the vertical structure of the project, each serving a distinct role in the system. Slices are subdivisions within a layer, isolating specific business features or entities. For instance, cart within the features layer or user within entities. They ensure functional separation. Segments break slices into granular parts, such as UI components, business logic, or API calls. Common segments include UI, model, and API, providing internal organization within a slice. This layered approach, combined with slices and segments, creates a systematic hierarchy that mirrors business logic rather than technical file types, setting FSD apart from conventional structuring methods. The app layer forms the foundation of an FSD-based project. It serves as the global entry point, housing critical configurations and infrastructure. Within this layer, you'll find the main application file, alongside routing definitions in state management providers, such as Redux or context setups in React applications. Its primary role is to initialize and connect the entire system, acting as the backbone that supports all other layers. The app layer is intentionally lightweight, focusing solely on orchestration rather than business logic. Also, the app layer, as well as shared layer, doesn't have slices and made up of segments directly. Next, the pages layer defines the application's navigational structure. Each slice within this layer corresponds to a distinct route or view. Examples include home, profile, or dashboard. These slices integrate presentation and logic specific to their respective pages, serving as containers that assemble components and features for user-facing endpoints. The pages layer ensures that routing logic remains isolated and aligned with the application's visible structure. The widgets layer is dedicated to reusable UI elements that lack ties to specific business logic. Slices here might include header, footer, modal, or sidebar, components designed for portability across the application. Unlike features or entities, widgets prioritize visual consistency and structural utility over functional behavior. This layer enhances modularity by providing standardized building blocks that can be leveraged by pages or features without introducing unnecessary dependencies. The features layer is the heart of user interaction within FSD. It encapsulates the application's core functionalities, slices such as add to cart, login, or search. Each slice in this layer addresses a specific user action or capability, combining UI, business logic, and data interactions as needed. The features layer is where the application delivers value, making it a critical component for implementing business requirements in a focused, isolated manner. The entities layer models the business domain, defining the core data structures and their representations. Slices here correspond to entities like product, user, or order. Within these slices, segments typically include type definitions, UI components, and basic data handling logic. This layer establishes a foundation of reusable, domain-specific abstractions that other layers, particularly features, can build upon, ensuring consistency across the application. The shared layer acts as a repository for universal resources. It contains slices such as UI for basic components like buttons or inputs, lib for utility functions, and styles for global CSS or themes. This layer is the lowest in the hierarchy, designed to be dependency-free and accessible to all other layers. Its purpose is to eliminate redundancy by centralizing commonly used tools and assets, maintaining simplicity and efficiency. A defining characteristic of FSD is its strict hierarchical dependency flow. The layers form a unidirectional structure, shared at the base, followed by entities, features, widgets, pages, and app at the top. Lower layers can be imported by those above them, but reverse dependencies are strictly forbidden. This rule prevents circular references, preserves layer independence, and ensures that changes in higher layers do not destabilize the foundational ones. Adherence to this hierarchy is essential for maintaining a clean and predictable architecture. Another cool feature in FSD is public API. Basically, it is encapsulation that is enforced through a public API mechanism via index.ts files. Each slice, whether in entities, features, or another layer, exposes only what is explicitly defined in its index.ts. Internal details such as implementation-specific files or helper functions remain hidden from external access. This approach mirrors encapsulation in object-oriented programming, where a class restricts visibility to its public interface. By mandating imports through index.ts, FSD decouples modules from their internals, enabling seamless refactoring and reducing fragility. Direct imports bypassing this API, such as targeting a specific subdirectory, are discouraged, as they violate isolation and increase coupling. Let's evaluate the advantages and drawbacks of FSD. Advantages: it enhances scalability by isolating changes within slices. It facilitates team collaboration through clear module boundaries. It simplifies maintenance and refactoring due to encapsulation and hierarchy. Disadvantages: the initial learning curve can be steep, particularly for developers unfamiliar with its rules. In small projects, the structure may feel overly complex or redundant. Strict enforcement requires discipline and tooling to prevent accidental violations. FSD excels in medium to large projects where structure and clarity outweigh its overhead. Let's summarize. Feature Slice Design offers a disciplined framework for code organization, leveraging layers, slices, and segments to ensure scalability and maintainability. Its hierarchical structure and encapsulation principles align closely with object-oriented programming, providing a robust foundation for complex applications. While it demands an initial investment in understanding and adherence, its benefits, streamlined collaboration, simplified refactoring, and clear boundaries, make it a valuable approach for medium to large projects. If this overview resonated with you, I'd like to hear your thoughts. Let me know in the comments if you'd be interested in a detailed walkthrough of a full project implementing Feature Slice Design with TypeScript, Next.js, and other modern tools. Your feedback will guide future content. Thank you for watching, and please consider subscribing for more technical insights.